I'm doing yearly classes also side by side. And whenever you want to see a paper, you can see it on my website also, on the YouTube channel also. June 15, 22. And the topic today is kinematics, one of the most important topics along with dynamics. So kinematics is something which comes in every paper. A stone is thrown vertically upward. The variation with time of the displacement of the stone is shown. This is a displacement time graph. It is going in negative also. So he says use figure 2.1 to describe without calculation the speed of the stone from 0 to 3. So I have described AB. A to B, speed is decreasing and it becomes 0 at B. What about B to C? Gradient increases.
How does it become 0 at B?
The highest point, not turning point, gradient is 0. It's a displacement time graph. If it is a displacement time graph, can you tell me what is the gradient?
The velocity.
Yes.
Okay, so 0 gradient, so 0 velocity.
No, is zero gradient means 0 velocity. Can you tell me what's happening C to D? Why displacement is negative?
Because it has fallen below the mean line.
Yes. Assume air resistance is negligible. When examiner says air resistance negligible, it means acceleration is equal to g. And therefore, the stone has constant acceleration. Calculate for the stone the speed at 3. He wants to get the speed at 3. So can we get the velocity at 3? We can read this. There is no scale on y-axis. There is no scale on y-axis. And he just says that at a speed of the speed at 3 seconds, but there is no marking. There is marking on x-axis, but there is no marking on y-axis. So how we can manage this question? It has a constant acceleration. So I have a speed at 3 seconds. If I start the stone has started from 0. It is thrown vertically upward, and then it is going in negative displacement. It's giving 3 marks.
So A is equal V minus U over T can be used.
Yes, that's a good idea. But how we can get the, he says calculate for, how we can get the acceleration? We can take it equal to G, but how much motion should I take? The main point is there. Should I take the whole motion, or should I take the motion C to D? Because A till C, displacement is 0. At the highest point, velocity is 0. The main important thing is that what part of the motion should I consider, where I can get the data?
C to D.
C to D, the problem is that I don't have speed at C. I have a speed at B. You remember the speed at B is 0. So this is the tricky part because you can't consider the whole motion. So I consider B, C part. No, sorry, B to D. Yes, because I need to find 3 seconds. Now, can you help me? What is the speed at B?
0 at B.
Good. So U is equal to 0. Can you tell me it's going upward or downward? It was thrown upward. So this much portion, the stone is going upward.
B to
And
D is downwards.
yes. So I got this idea that it's going downward. So I will be taking positive G. What about time?
3 seconds.
No, how it can be 3 seconds?
Almost
You know that I'm
1 point.
taking. This is the point. This point is 1.5. So what is the time of B? It's between 1 and 1.5.
1.25.
Very good. So I marked 1.25. How much is 3 minus 1.25?
1.75.
I have made the data. This is the tricky part of this question because you have to select a part of the motion.
It is coming as 17.16.
Can you repeat?
17.16.
How many significant figure? Okay, I have to take 2 sig figure. The distance traveled from 0 till 3. Is it a case of area?
This will be done by counting the squares.
Yes, a very bad example here, but I fear we have to use this. Or if you think of any other equation of motion, we can save time because box counting is the last resort. We have a good amount of data. Box counting is not wrong, but box counting should be used when there is no other option.
So S is equal UT plus half AT square.
Right, but for how much range should I use? I should consider the journey in 2 stages because full journey I cannot cover. I can do a part of the journey A to B. and then B to D, because I have data according to that. The problem is that problem is the same. How I can find the distance AB? I don't have the actual speed. I can find it by tangent gradient, but there is no marking on y-axis.
Then box counting we won't even work because we don't have the y-axis.
Yes, now you got the point. Box counting is not possible here because he has cleverly left the marking. So now can you tell me that if I travel A to B and I travel B to C, will it be the same?
Yes.
And B to C, I have data. So if I take B to C, which I'm taking for A to B actually, what should be the initial velocity?
0.
What should be the time B to C?
Almost like 1.25.
Yes, because 1.25 is already half of it, na?
It is coming as 7.7 meters.
Now, consider distance of B to D. How much time should I take? I should take 1.75 as I calculated before.
It is coming as 15.02.
So what will be the total distance?
It is 22.7.
$22.7 meters. The displacement from 0 till 3. Now that's a tricky part. Displacement 0 till 3. Huh? So 0 till 3 means there is some area above x-axis and there is some area below x-axis, because it has changed the direction, right? So how should I add them? I have added just now AB and BD, or should I subtract something?
Won't A to C be 0, the displacement?
That's a smart approach. A to C is 0. And if you can take C to D, that would be the resultant displacement. You can try that idea. Displacement A to C is 0. So what left behind is C to D.
So we'll take 0.5 seconds and do it. Like we can use S is equal to UT plus half AT square.
We can take 2.5 to 3. And what is the velocity when it reaches? We have the final velocity at C. We don't have velocity at C, we have velocity at D.
Isn't it constant because it's a straight line?
No, it's not a straight line. If you look closely, it is not a straight line. It's a curve. We don't have the velocity at C. Acceleration is constant. We don't have velocity at C, but we have velocity at D.
So for C, we'll have to find out the velocity by using V is equal to U plus AT first.
I think so. Because it's going in negative.
But we don't have the initial velocity as well.
But we have the acceleration and we have the time. So there should be a way to handle it. Or we can try V is equal to U plus AT. First, we should find the initial velocity. First, we tell examiner that A to C displacement AC is 0. Now, the velocity when it reaches the 3-second mark was 17.16. This is the data.
So we can find the velocity at C by this.
Yes. I've shown the working. First, you should help me to get the value of U.
U is coming as 3.49. The answer is coming as 14.38.
Answer is coming 14.38. Now we are in a problem because AB was 7.7. So if AB was 7.7, BC would also be 7.7. That's around 15. But how this much small distance can be this much big? Can you check your calculation again? Something is wrong because it can't be 14 because the top total distance above x-axis is approximately 15.
Okay, I think there was a wrong in the initial velocity. It's 12.255.
Okay. Can you repeat
255.
12.255?
Yes.
Okay. So
Now it is coming as 7.35.
that makes sense. The direction would be downward. It's a negative case. Even though it's very technical, but there is another method of doing such a question because we already had calculated the distance AB. The distance AB was 7.7. So I just want to explain another possible way that if we take this much, it is 7.7. So this will also be 7.7 because it's symmetrical, right? So the area 7.7, then 7.7. If you see the area B to D, the distance B to D, the distance B to D, you can see the distance B to D was 15.02. So it means if I, 15.02. So if I take distance B to D is 15.02. So what should I do to find the distance below x-axis? There was another way. I take 15.02 and subtract from it 7.7 plus 7.7. This would be a direct method. Even though it's very technical, but 7.7 plus 7.7 means the total area plus 7.7 means the total area above x-axis, and B to D is 15. So if I subtract them, I will get only the distance C to D. Did you get this idea?
Yes, first we will find out the CD, then we'll minus it from.
We have C to D, na? No, C to D we are finding. We are looking for C to D actually because the first part is 0, na? As we already have mentioned. So we could do it by this method also. It was a choice. The figure on figure 2.2, draw the variation with time of the velocity of the stone from 0 till 3. This is the sketch. And this is the description. Examiner already had mentioned constant acceleration. So if I'm going to draw velocity time graph, will I get a straight line or will I get a curve?
A curve?
Yes, think again. Constant acceleration,
And a
constant
straight line.
yes, a straight line. First part, he says speed decreases until V 0 at B. Already we have mentioned, na? So I should make a line. Now the problem is here, drawing a line is a big challenge. We can start from any number because we don't have the initial speed. So we can start from any number. We will take this point and we can take any point from here. Like this. It's not a straight line, although, but it should be a straight line. But I don't have a ruler available on this software. So what should we do after that?
Then a constant gradient. Like 0, if the velocity is 0, the gradient will be, acceleration will be 0.
But should I show a decrease in speed or increase in speed?
A decrease. No, at the maximum point, it will be 0, then the speed will increase.
Velocity should be negative because it is taking a U-turn at B.
Yes, it will go downwards then.
It will continue to go downward until it reaches
Terminal velocity.
yes. No. Until it reaches C. This is the position C. C or D? 1 minute. Until it reaches position D. It's a straight line, even though I'm not able to draw it because it's not offering that option. This is the graph. It should be a straight line. The figure shows an object M on a slope. M moves up the slope, comes to rest at point Q, and then moves back down the slope to point R. So it's a whole story. It goes up, stops, and then returns at R. M has a constant acceleration of 3 down the slope at all times. At time 0, M is at point P and has a velocity of 3.6 up the slope. The total distance from P to Q and then R is 6 meters. Calculate for the motion of M from P to Q. It's going upward. Is asking for the time taken. So can you make the data for me?
The final velocity will be 0.
Initial is 3.6.
And we don't have the distance. First, we'll take out the distance, I think, and then divide it by the velocity.
We can try that. Because the mass is not given. He has given us the total distance. Acha, he has given us acceleration 3.
But it says down the slope.
No, it's a language. Otherwise, look what he says for velocity up the slope. It's a language. Acceleration is down the slope all times. All times means throughout the motion, even when it is going upward, acceleration is down. Why acceleration is down the slope? Because resultant force must be acting down the slope. That is why it's coming back. It means for the upward motion, it will be a negative acceleration. It would be a retardation.
It is coming as 1.2.
Then he says the distance traveled from P to Q. So it's a game of equation. I should make the data again. Now I have made the data.
Can we do it like 3.6 into 1.2 directly?
No, but it's not a straight line, not a constant constant speed. No? That formula would be valid when the speed is constant.
It is 11.38.
Sorry?
11.38 meters.
11.3. Acha, sorry, my mistake. Actually, you know what I did? I mistakenly put acceleration 9.8. It's not 9.8, it's -3. Sorry.
It is 2.16 meters.
So that the speed of m at r is 4.8. Now he says speed of m at r is 4.8. He has given us the total distance P2Q and then r is 6 meter. P2Q and then r is 6 meter and we know the distance PQ. I'm just making an equation. Now, this is the equation.
It is coming as 3.84.
Three point
84. But it says it should be shown as 4.8.
no, this is the distance now. I have found the distance QR. So what I'm planning to take the motion from Q to R because there is a U-turn involved. So first we took P to Q and now I'm planning to take the motion Q to R. Can you check what's the speed at Q?
0.
0. Good. So now consider the motion Q to R.
It is coming as 4.8.
You have taken the under root also?
Yes.
It was to show, right? The figure 2.2, draw the variation with time t of the velocity of m for the motion p to q to r. Acceleration is constant. So what is the velocity? First, I consider p to q. What is the velocity at p? 3.6.
So decreasing.
And velocity at q is 0. The time taken was p to q, time was 1.2. Where is 1.2 now? 1.1. I'm marking 1.2. And here I have to mark what is the velocity at 3.6. Okay, 3.6. So which should be 3.6, 2.4, 2.8, 2.3 point. I should take 0.4, 0.4.
Yes, like one block below 4.
3.6. Again, I have a issue of drawing today because this software is not supporting. Oh, this software is not supporting straight lines. Well, I have to connect. Somehow it's connected. Then this is P, this is Q. Now, what should I do for R, Q to R?
Also in the exams, can we use pencils for the graphs?
Graph you have to draw with pencil definitely. Should I go below x-axis for the remaining motion?
Yes. Because it's coming in.
4.8. And what is the time span? How should I get the time? I have 4.8, but how much time it takes? Or should I take the same line? Has he given any time for? I can find the time, but I have the distance, and I don't have the time. He says acceleration is 3 for all times. Acceleration is the gradient. Do you expect the line to change its gradient beyond Q, or it will follow the same gradient?
It will change.
No, he says acceleration is 3.
Then it will be same.
Yes. I'm taking it to this line like this. He says the mass of M is 450 gram. Calculate the difference in the kinetic energy of M at P and R. Velocity at P is 3.6 and velocity at R is 4.8. Can you get the calculation for me?
It is coming as 2268.
I have rounded it to 2300. Even though it's looking to be a very big number.
I think I just took 450 as it is. I have to take 0.45.
Oh, because I was thinking why this energy is coming so large. Just divide the same answer by 1000.
It's 2.268.
So that's all, and we will continue in our next class, and that's over. We are doing kinematics because these topics were not done in our regular section, and obviously the time is very limited. If you come across any query, you can always tell me. So it's up to here. Allah Hafiz.
Allah Hafiz.